Hello everybody. So, you know how acids and bases are? Acids are fun because they can break materials down, they can reduce materials, they can make new compounds, such as baking soda and vinegar, for example, which produces those new chemicals, or commonly known as hot ice, sodium acetate. So the chemistry behind it is quite simple. And the way you check it is using your pH scale. Normally a pH scale goes from 1 to 14 in simple examples. However, you can go more in depth, such as 0.1 or so on and so forth. So, I've got here some acetic acid and sodium hydroxide, two commonly used household chemicals. Right, and we're going to be measuring them and see what happens when we mix them. So, your acetic acid is an acid, so it should be below the pH scale. That's why you can see it here turn red. And this red color would indicate that it's got a pH of 2. Not easy, but in theory, that's what it is, right? But then you got something like your sodium hydroxide, which will have a different pH, because remember, sodium hydroxide is a base, and that means it would be above your pH scale, which means, yeah, it should change a simple green color. And that pH is pH number 9. So now you've got your two samples here. But the main question most of you would love to know is what would be the neutral point of the pH, or the point where the one is stable, shall I say, the point where they both are safe. Well, the normal method for that would be 7. 7 is a safe point. Anything at 7, put it that way. 7 is your safe house, if you shall say. Now remember, this is an acid, this is a base. Two very distinctive colours, shall I say. Red for dangerous, green for, I suppose green is normally referred to as safe, but under these circumstances, green isn't safe. It just, yeah. So let's take one of these new test tubes, pop the cap on them, and see what happens when we mix an acid and a base. So I'll start off with mixing the sodium hydroxide solution. Now, sodium hydroxide is a common chemical. It's commonly used for making of soaps. So let's pour some of that in there. Oh, what a beautiful amount. And let's take some of your acetic acid. Notice how it fizzles over. And so that proves that this chemical has now reacted. That fizzing is chemical change, if you shall say. And that chemical change should be now measured. And the pH you should get is 7. Right? So let's take a strip and let's measure it. So, let me grab my trusty tongs. Well, tweezers actually. And let's dip it into the solution. Well, what do we have here? The pH strip never changed, proving that it's a neutral solution, which technically means it's 7. And so that is how you would normally do such things as measure pH, or you'd do such things as tell the difference. Depends on which, first of all, also can depend on which pH paper you use, where in this example, the first one went red, to prove that it's an acid, or reddish orange, and then the base went green, and the neutral one never changed, where you get more precise ones. However, for this demonstration, we're using the standard version. So, you've got your acetic acid, which has a pH of 2, and you've got your base, which has a pH of 8. What a surprise.